Welcome to our lecture on materials science, focusing on the fascinating world of addition polymer structure. Let's dive into the intricate details of how these polymers are formed and their unique properties. By the end of this class, you will be able to describe the general types of chemical structures for addition polymers and identify important polymers for each type of chemical structure. Let's explore these objectives in detail. Understanding the degree of polymerization and molecular weight is crucial. The degree of polymerization, denoted as In, and the molecular weight, represented as the weight of the mer times In, are key concepts in polymer science. Polymerization involves the opening of double bonds in ethylene mer units, forming long chains of polyethylene. This process is fundamental to creating various polymer structures. Let's test our understanding. What is the molecular weight of the mer below? And what is the molecular weight of the polymer if the degree of polymerization is 100? Take a moment to think about these questions. Here are the possible answers. Calculate the molecular weight based on the given degree of polymerization and select the correct option from the answer bank. The molecular weight of polymers significantly affects their properties, such as melting point. For instance, the melting point increases with more carbon atoms in the chain. Let's compare the properties of candles and plastic milk containers. The elastic modulus of polymers is 2 orders of magnitude less than metals or ceramics. This difference is due to the molecular weight and bonding characteristics of polymers. Let's delve into why this is the case. Consider these questions. Which polymer will have the lowest melting temperature with varying degrees of polymerization? And which polymer will have the highest yield strength? Reflect on these inquiries. Based on your understanding, select the correct answers from the options provided. This will help reinforce your knowledge of polymer properties. Free radical polymerization involves 3 main steps: initiation, propagation, and termination. Each step plays a crucial role in forming the polymer chain. Let's examine these steps closely. Vinyl-type polymers, such as polyethylene and polyvinyl chloride, have distinct properties and applications. Understanding their chemical structure helps in identifying their uses in everyday products. Diene-type polymers, like butadiene and isoprene, can form extra double bonds, making them cross-linkable to become elastomers. This characteristic is essential for creating flexible and durable materials. Teflon, a miscellaneous addition polymer, is known for its non-stick properties and high resistance to heat. Its unique structure makes it ideal for various applications, from cookware to medical devices. Vinylidene-type polymers, such as PMMA and PVDC, have specific properties that make them suitable for applications like musical instruments and fashion accessories. Let's explore their chemical structures and uses. Which term is not associated with addition polymerization? And what is a thermoplastic analogous to? Take a moment to consider these questions and select the correct answers. Review the options and choose the correct answers. This exercise will help solidify your understanding of addition polymerization and the characteristics of thermoplastics and thermosets. To recap, our learning objectives were to describe the general types of chemical structures for addition polymers and identify important polymers for each type. Reflect on what you've learned and how these concepts apply to real-world materials. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video to share your thoughts and questions. What did you learn from the video? What topic would you like to explore further? This presentation contains copyrighted material used under the Fair Use Doctrine for educational, commentary, and research purposes. All rights belong to their respective copyright holders. Links are provided in the video description to relevant resources.